let's take a look at the centroid and orthocenter of triangles. Alright, so before we get into the centroid of a triangle, we first need to know what the median of a triangle is. And that is simply a segment that joins a vertex to the midpoint of the opposite side. So x is the midpoint of RP, and we know that because Rx and XP are congruent because of these congruence marks. So that would make x the midpoint, which would make QX the median of this triangle because Q is a vertex and it goes to the opposite side, cuts it in half into two equal parts. So that would make QX the median. So the centroid is the point of concurrency for medians, or it is where the three medians would intersect or meet in a triangle. And remember, a median is created by a vertex connected to the midpoint of the opposite side. So the centroid here would be P, because it is where all of these medians intersect. Our medians here are AE, BF, and CD, because all of these go from a vertex to the opposite side, and it cuts that opposite side into two congruent parts. And we know that because we have these congruence marks here on each side. So those are all medians. And let's look at some properties for each median. So let's take AP, or AE for example, the first one that we listed. So since AE is a median, AP is equal to twice PE. Or we could say that PE is half of AP. So as an example here, if AP, let's say AP is 4, PE would be half of that. So PE would be 2. And so the length of AE would be 6. So that is how we could figure out what the length of a median would be if we're given some partial information there. Also, AP would be 2/3 of AE. So 2/3 of the entire length of the median, and PE would be 1/3 of the length of the median. All right, so let's look at some problems involving the centroid. So let's look at this problem here with centroids. So remember that the centroid is the point of intersection for the medians. So medians go from a vertex to the opposite side and cuts the opposite side in half into two equal parts. So let's go ahead and just draw some congruence marks here. So that would make KN congruent to NL, JO congruent to OL, and KM congruent to MJ. Because if P is the centroid, that will make each of those segments congruent, because M, N, and O would be midpoints. So let's look at our given information here to find each measure. It says JK is 22, so let's just label that on the triangle here. KN is 13, so right here, and OL is 18. So we want to find, looking at this first one, we want to find KM. So if JK is 22, that will make JM as well as KM or MK each 11 because they're congruent. So KM would be 11. What about NL? NL is congruent to KN, so NL would also be 13. Let's look at KL. So since KN is 13, NL is 13, we could simply add 13 plus 13 to get 26 for KL. What about JO? Well, JO is congruent to OL, so JO would of course be 18. Last one here, we want to find JL, so since JO is 18 and OL is 18, we could simply add 18 plus 18 which will give me 36. So let's take a look at this problem here. Z is the centroid, right? So let's go ahead and just label this as a centroid. We know that each of these sides are congruent right here. Should be 3 here. And let's label everything before we try to find these measures. It says that TZ is 60. So TZ is 60, so we have a portion of our median here, right? It says that XZ is 28. So XZ is 28. And it says that WZ is 25 right here. So that is our given information. So let's find the measure of what we're asked for right here. So we want to find ZV. So ZV here. So since XZ is 28, ZV would be twice that. So 28 times 2 would be 56. All right. So ZV would be 56. I like to label the triangle there. And so we're asked to find ZY, which is here, right? And so since TZ is 60, ZY would be half of that, right? So 60 divided by 2, or 60 times 1/2 would be 30. So ZY would be 30 using our information from the previous slide there. So let's look at ZU. Okay, so we have WZ, right? WZ is 25, so ZU would be twice 25. So ZU would be 50. All right. So now we want to find TY. So since we know that TZ is 60, ZY is 30, we could simply add 60 plus 30. That gives us 90. And the last one here, we want to find XV. Where is XV? Okay, so it's the length down right here. So we found the length of VZ, which is 56. And then we know we were given that XZ is 28. So we could simply add those two, and we get 84. So we found the length of some of the medians and a portion of some of these medians in this triangle. All right, so I would like for you to try this problem on your own. Go ahead and just pause the video, analyze this triangle, and see if you could find the measures that you're asked to find right here. So go ahead and pause and try this problem here. Okay, so hopefully you got them correct. GD is 4, AD is 12, CG is 14, GE is 10, and BE is 15. And it really helps to look at the triangle and see what you're given in order to find the lengths of these measures. So let's take a look at the orthocenter, and that is the point of concurrency for altitudes. And altitudes are created by a vertex connected to the opposite side so that it is perpendicular to that side. And so our orthocenter here would be point P, and our altitudes here would be AE, because if we look at A, it goes from a vertex to E, and it is perpendicular to this side because we have this right angle here. So AE would be an altitude, BF will also be an altitude, and CD would be an altitude. So again, the orthocenter is a point of concurrency for altitudes, or it is where all of the altitudes intersect in a triangle. A little more information about the altitude of a triangle. Again, it is perpendicular from a vertex of the triangle to the opposite sides, as you can see with these three examples, or these three images here. We have altitudes there. So the concurrency of altitudes theorem states that the lines that contain the altitudes of a triangle are concurrent, or they meet at the orthocenter of the triangle. The orthocenter can be inside, on, or outside of the triangle. So as you can see these three figures here, for an acute triangle, the orthocenter is on the inside. For a right triangle, the orthocenter is on the triangle. And for an obtuse triangle, the orthocenter would be on the outside of that triangle. So let's use this information that we're given to find an orthocenter on a coordinate grid. So it says triangles with vertices A 1, 3, B 2, 7, and C 6, 3. What are the coordinates of the orthocenter of triangle ABC? So the first thing we want to do, we want to draw some altitudes. So we start out by drawing one altitude. And an easy one would be starting at point B, straight down, because that is actually on the grid. And that is the line x equals 2, because if you were to keep extending that line, it will cross the x-axis at x equals 2. Let's draw another altitude. So we want to draw another altitude. So we can see that the slope of line BC is -1, right? Because down 1 over 1, down 1 over 1. So the slope of that line is -1. We need a perpendicular slope because we want to draw a line that is perpendicular to BC. So remember, perpendicular is opposite reciprocal. So the perpendicular slope to line BC will have a slope of 1. So we can draw a line from point A that has a slope of 1. So our vertex A here, we could draw a line from that point that has a slope of 1. So as you can see, up 1 over 1, that's 1, up 1 over 1. All right, this is a 1. So our slope is 1, and that is the equation y equals x plus 2, because if you were to keep extending that line, right, it will cross the y-axis at 2. All right, if we would go back 1, down 1, my y-intercept would be 2. And so my equation for that line would be y equals x plus 2. And so the last thing we want to do is just simply find where those two lines intersect. So where do the two altitudes intersect? They intersect at this point here, and that is the ordered pair 2, 4. Therefore, the orthocenter is 2, 4. So now, how would you find the orthocenter without a graph or a grid if you're given that information? So after you found the equations, right? So y equals x plus 2 and x equals 2. You could simply set up a system of equations. X equals 2, y equals x plus 2. You could use substitution to solve that system. So since x is 2, you could simply take 2, plug it in for x, all right? 2 plus 2. So y would be 4. And again, we would see that our orthocenter is 2, 4 because our x is 2 and our y value is 4. All right, so we reached the end of our lesson here. So I want to thank you for learning with me. Some related videos are circumcenter and incenter of triangles and centers of triangles. If you would like, please like, comment, share, and if you haven't already, subscribe to Peach Pie. And once again, thank you for learning with me.